Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and today the first article we have is the following paper here. So, this first article is about a paper that analyzes the possibility of costs and carrying out attacks on Bitcoin and Ethereum, specifically those that would breach their security thresholds. So on Bitcoin, it's the 51% attack, for example. And the authors introduce a new way to measure the cost of these attacks. They called it the total cost to attack, TCA. We'll see a graph later on, which takes into account both the operational costs and the investments needed to perform such an attack. And these attacks have happened in the past, although on smaller chains, for example, on Ethereum Classic. This is not the same Ethereum as they analyzed in their paper. And in 2020, 251% attacks were carried out on Ethereum Classic, and the attacker could successfully double spend 1.68 million US dollars. And this paper, it does not consider any kind of other hacks, just the double spend, because we know there are still many hacks going on. Here's a good list of DeFi Llama. So the last hack happened end of January, and something about borrow logic exploit where 6.5 million US dollars were stolen, but these attacks are not considered in this paper. Their research finds that attacking Bitcoin and Ethereum is currently not economically worthwhile, suggesting that the security of these networks is strong enough to deter potential attackers. And they showed a nice graph down in the paper here. So their final result, they described the approach they took. So this graph here. And they come from a naive model here, the brown line down here, just buying hardware for the current prices, and then they refine their cost model. For example, they consider the price effects on the hardware market, meaning that if you buy lots of hardware, the demand increases, so does the price. They added electricity, and so the range of a 1 hour attack on Bitcoin is estimated from here the lower bound of 5 billion US dollar to over 20 billion US dollars. So somewhere in between is the cost of the attack. Very interesting paper. The next article is about NGINX. And as a reminder, NGINX was bought by F5 in March 2019 for 670 million US dollars. And now Maxim Dunin here, he's one of the few core developers. He launched free NGINX to continue NGINX development independently from F5. He aims to maintain the project's integrity and openness of the disagreements with F5 management, and this initiative invites contributors and seeks to keep NGINX development free from corporate influences. In this lecture series, we'll be covering NGINX as an example when we discuss the topic of load balancers. So let's see if we can use free NGINX. The last two articles are reminders that hardware can fail, In the first lecture, I'll present three main reasons for distributed systems, which is scaling, location, and fault tolerance. And these two articles, they are about fault tolerance. So the first article here is about the state of ECC. In 2024, ECC stands for Error Correction Codes, and it's built in some RAM for your computer, depending on if you're on the desktop side or if you're on the server side. On the server side, it's standard use ECC. On the desktop, it's not. And this article, in this article, the author observes that beginning of 2024, there are a couple of options for using ECC in your desktop computers. For example, he mentioned the Intel chipset W680 that supports ECC, but also the AMD Ryzen 7000 series and AM5 motherboards, or some of the motherboards with that chipset. They support ECC, and they offer potentially lower cost alternatives to the expensive server hardware. And he finishes the blog with the following very interesting sentence down here: whether ECC makes a meaningful difference that's worth paying for is a bit of an open question. As I mentioned, we'll be covering this topic in the first or in the second lecture. And the last article, in this article, the author discusses strategies for maintaining long-term reliability of Raspberry Pis, focusing on preventing common issues like Wi-Fi failures, software crashes, and SD card wear. And he emphasizes the importance on choosing the right SD card, avoiding swap, and considering file system checks for non-read-only file systems to extend the operational life. And here the first sentence of this blog caught my attention. Sometimes, through no fault of your own, something deep down will cause your Raspberry Pi to crash hard. I will explain in the lecture that hardware can fail, hardware will eventually fail, and this is a good motivation for distributed systems.